You've already watched the first video to see how we set up the apparatus for this capacitor discharge experiment. What I'm going to show you now is how we use the data logger in order to collect the data for this experiment. So you can see here I've got the potential difference being recorded because the sensor has been plugged into the data logging software, and at the moment the capacitor has been completely discharged. If I take out the flying lead and connect it to the power supply, you can see that the potential difference is going up, and if I wait long enough it will eventually reach the EMF of the power supply. But before we actually do that, I just need to set up one or two things in order to collect the data. So first of all, I can use this setting here to change the settings. As you'll see, I've suggested that we collect the data over 20 seconds. Importantly, what we're doing here is we're going to be recording data at a very high rate. We're going to record 250 samples every second there. So that's set it up such that we can start recording the data there. Now you'll see that the potential difference across the capacitor is stabilized reasonably well. So what I'm going to do is I'm going to start collecting data. When I can see the data is being collected by the data logger, then I'm going to move the flying lead onto the discharging part of the capacitor, and hopefully you'll see the results being collected there. So let's have a go at this one here. Press collect, and I can see data coming in there. I'm going to move the flying lead, and immediately you can see that we're getting a nice exponential decay on that data collection there. I'm going to wait until it finishes. I've asked it to continue up to 20 seconds. It will eventually get to that point there. So there's our graph, and you'll see again on the instructions that I can use this option up here to auto scale the graph. If I click that one there, then you can see that there's our capacitor discharge curve. You'll see that on the analysis, it suggests that step one is that you should sketch that graph there. So you may want to pause the video at this point here so that you can sketch that graph there. The next part that we're going to do is that we're going to try to use this data to plot a straight line graph. In order to do that, I need to create a new calculated column. So on the data logger again, it says new calculated column. So this time I'm going to get the data to plot the natural log of the potential difference. And it's the potential difference measured in volts. Let's just give it that as a short name as well. That's the name that I've got there. This is where I'm going to do the calculation. So the function I'm going to choose there is the natural log, and the variable that I'm going to put in there is the natural log of the potential. If I do that one there, you can see that in the table of data, it's also calculated the natural log. So now we can insert a new graph. So if I insert a graph there, and you'll see that again, it's chosen to plot the natural log of the potential difference against the time there, and we get a graph that looks reasonably like that. So that is step 3 on the experimental sheet, and you can see that you've got a reasonable graph there. Again, you may want to pause the video at this point here just to sketch that graph in your sheet there so you can understand what's going on there. As one of the extensions, we'll be talking about why this behavior might be happening down there. You can think about that. But now we're getting to step 4 on this one here, where we can use this graph to do some data analysis. So you can see in this region here, I've got a reasonably straight part of the graph there. So what I'm going to do is highlight that part of the graph there. I'm highlighting about 4 seconds of data there in the reasonably linear part there, and up here I've got an option that says try and fit a straight line graph to that. And you can see, hopefully on the video here, the data that we've got a correlation of -1.000, which gives a very good answer there. And it also displays the slope and the intercept of that one there. The intercept in this occasion doesn't mean anything but you'll see on the sheet there that it asks you to record the slope. So at this stage here, we're virtually finished with this experiment. What I'm going to ask you to do is record the slope, and from the instructions on the sheet there, you should be able to work out the time constant from that data. The final thing that we need to do in step 4 of this experiment is actually try to calculate the capacitance of the capacitor. Now, the instructions tell you to go and get a data logger to record the resistance of the resistor. I've done this for you, and the resistance of the particular resistor I was using here was 998 ohms. So you can record that value again in part of step 4, and using that you should now be able to calculate the true value of the capacitance. This almost certainly will be quite different from the declared value of 2000 microfarads. So the final part to step 4 is to calculate the percentage error, the difference between the declared value of the capacitance and the actual value that we've measured using this experiment. That completes the main part of the experiment. There are 2 more steps, 5 and 6, that if you have time you may want to fill in those extension parts there.